Hello, everyone. This is Colleen Lumsden, and on behalf of Aspen Mesh and 451 Research, I'd like to welcome you and say thanks for attending today's webcast titled Operating and Debugging Istio in Production. Leading off the discussion today will be William Fellows, who is co-founder and research vice president at 451 Research. Following William will be Zach Arnold, who is VP of DevOps Engineering at Ygrene. After Zach will be Neeraj Poddar, who is co-founder and engineering lead at Aspen Mesh. Just a few quick housekeeping items before we get started. To ask a question, simply type it in the question box on your screen, and we will get to as many as we can. The presentation slides are available for download in the resources section on your screen. And finally, please check back for the on-demand version of this webinar after the conclusion of the live event. And with that, I'll turn it over to William.
Hi, thank you for those kind words and remarks, and welcome everyone. Thanks for taking the time today. Service Mesh is an interesting and wildly kind of exciting sector at the moment. The range of inquiry and interest which we get is tremendous. I just want to make sure that you can see my slide here, because I'm not getting a button which says move it along. So sorry about that. So what I wanted to do was just to frame up the landscape then before the other folks get a bit more forensic about what's going on here. The way we at 451 Research understand and sort of look at the market is that there is a kind of a veritable feast of things that are available to end users in the market, and we're really entering a time when essentially cloud consumption is overtaking cloud building as the primary driver of IT spending. And of course it's underpinned by enterprise workloads being on the move and the replatforming to cloud and cloud native hitting the mainstream. Now 451 owns and operates a panel of enterprise IT end users, and when we've asked them what is the primary workload deployment environment for their workloads now and in 2 years' time, the top line is that 73% said it would be their primary deployment environment by the end of 2021, up from 49% this year. But probably more interestingly, all cloud venues are the beneficiaries here, both public, private hosted, and private on premises. And the kind of subtext also is that the tremendous rise in the use of off-premise environments from 48 to 65% as the primary workload deployment environment in that same period. So if cloud is the venue, that's very much the infrastructure view, and that's well underway. I think where we are now is at the application view. And here, cloud native provides the platform here, the new sort of ingredients, if you like, for this feast, from containers and Kubernetes and microservices through serverless and service meshes and so on. Collectively, these constructs are where the industry puck is heading. Those are both technology views, but the cloud native piece is also the process view, because obviously anyone doing cloud native has got to do DevOps, because in the cloud, apps and infrastructure are the same thing. Now, the industry likes to say that while 90% of existing applications don't use containers, 95% of new ones will be. Well, at 451 we can be a little bit more scientific. This comes from our same Voice of the Enterprise survey of those enterprise IT end users. And these are the folks who have said where they are in terms of their adoption of cloud native technologies. Obviously, most advanced with containers, but clearly both Kubernetes and serverless now are rising in importance. So what we've done at 451 is to build this spectrum of abstraction just to try and understand at a high level what's going on here. And the way to unpack this is that, ultimately enterprises are using a variety of cloud-native technologies and methodologies to pursue, DevOps and digital transformation efforts. And they don't tend to compete so much as being used alongside one another. And usually to improve the sort of software release processes, across the organization. The sort of main difference between these various technologies is the level of abstraction provided to the users. And on the left is very much the sort of DIY approach where organizations can use sort of custom code and services and make their own choices on languages and frameworks and APIs and so on. And that's attractive for apps that require low latency and run longer compute jobs, for where high traffic can be sort of predicted. But on the other end, as the functionality becomes more abstracted over on the right, the infrastructure becomes more invisible, and here we see the serverless functions and events, and these are standardized and opinionated choices that are abstracted almost entirely away from the end user. And in between the two, other levels of abstraction, including supported Kubernetes distributions, container as a service, and so on. I think the other interesting thing here is that bridging between these different worlds, folks are able to build, consume, and have different management models within the same IT estate. I think that the fact that Kubernetes has sort of become king in this cloud-native digital era is sort of playing out, and it was evident at the recent KubeCon event down in San Diego. That sort of, if you like, Kubernetes sort of dial tone has pretty much been achieved. Our analysts felt, and most of the interest and activity was in the things that are being used inside it, on top of it, and around it, and so on. So, cloud native is super important in developing and lending momentum to DevOps within organizations. I mean, obviously DevOps emerges as a method to speed the process of building and testing and releasing software, but its corollary has been a shift in emphasis from managing the infrastructure to how software is deployed and updated and at scale and so on. Most infrastructure frameworks don't support this model, but Kubernetes does, in part through Kubernetes controllers and so on. It's easy to use infrastructure to manage the application lifecycle. So, we've specifically asked our survey group, what are the critical technologies important to DevOps implementations, and you can see here that those cloud native things are, super important in that. Even though, public cloud is cited on there, by 41% of respondents, I think it's also worth reminding ourselves that the bulk of DevOps implementations still, reside on premise and private cloud environments at the moment. So, what are the changes in cloud services that would improve an organization's DevOps implementation? So you can see here that the automation and as sort of comes out on top here, and I suspect that's a lot to do with the complexity, but also we think because automation in some sense is reaching its limit in DevOps with only when we just think about scripts and workflows, and that the next step is to make all the processes subject to inspection and automation that, if you like, thinks for itself in order to get the levels of efficiency and connectivity. And I'm thinking here, obviously, of the use of machine learning and AI ops techniques and so on, because I think we're within sight of applications being able to select and maintain the IT environment they require on their own, and a time when code can, well, either write or perhaps more importantly rewrite itself when it needs to. So I think generally what we're talking about here and learning from our end users is that the difficulty in automating the DevOps tool change is that really it traverses so many functions, and really the automation is required to break down those silos to remove friction from application delivery. And I think, well, one reason it's so difficult for DevOps and IT teams to wrangle is that at the same time they're making the business and culture shift, they're being slammed by this this complexity and unpredictability, and the tool chain really isn't mature at enterprises. There's still a lot of manual stuff going on, missing skills, especially around the infrastructure, and it's not sort of transparent enough yet either. The adoption is mostly at team level, I think, and that's hard to scale, and it's difficult to balance speed and governance in these environments. So where are we in the sort of replatforming to cloud native? And it's our view that it's very much the same way the industry replatformed to the internet and the web in the 1990s and 2000. This is well underway. I think it's pretty clear that the container is going to be the atomic unit underpinning this. And really, as the replatforming gathers pace, if you like, the real question is which applications in what sequencing are going into which venues over what period of time. That's the sort of what vendors are trying to understand in order to try and capture or to develop the services that can be the landing pads for those things. And really, as the worlds of outsourcing and hosting and managed services and cloud converge, these options are really sort of growing exponentially now. And we can see, the sort of different approaches to infrastructure really sort of converging. If we think about on-premise cloud managed offerings from the hyperscale vendors, as well as the sort of more pay-as-you-go on-demand offerings for more traditional vendors, those are starting to blur, and that will happen even more so. I think the run anywhere mentality that cloud native sort of mandates requires that the infrastructure will necessarily need to become more invisible to both the consumer of those as well as the expensive developer. The more time they have to spend on infrastructure, there's less time on doing the development piece. And I think that also implies that that these are going to be hybrid environments. They're going to require both local and regional and global reach where necessary, with not locked into any particular environment. I think there's been a sort of a question mark of insecurity hanging over the whole sort of cloud native thing, and I think it's going away. But it's I think IT ops has been traditionally regarded as secure, and development not so secure. And bringing those two together, if you can download a container from the internet and run it on your servers, that implies that there's a certain risk attached to that. But like I said, I think we're starting to move beyond that. What is not at question, though, is the importance of developer enablement. So if we just take it right back to, what's going on here, when we ask our commentators in the survey panel, they say, all of these new things, great, but they're still supporting, digital transformation, which remains the organizing principle here. And of course, organizations undergoing digital transformation want to be able to create digital services to better engage and serve customers and so on. And, those services are principally software, and so they therefore need to raise their software IQs mostly to do this, and developer enablement is going to be a critical piece of allowing that or enabling that to happen. And of course, the developer now has a much bigger role and say in application delivery. I don't think we've seen a killer app for cloud native, at least not yet. It's in a way, it's a bit like asking, well, what's a killer app for 5G? But interestingly, if we look at all the work that's going on over in the telco industry, who knows? 5G might end up becoming the killer app for cloud native, given all the things that they want to do in terms of slicing and dynamic service delivery and so on. I think the point is that like the sushi roll here, cloud native implies that everything is composable and software defined, and that leads us to the other piece with the with so many moving parts. There's clearly there needs to be a mechanism to be able to manage all of this, and service mesh is coming to view as really the answer to that. And there's a lot of excitement around service mesh with a good reason. I mean, enterprises currently use a huge range of different technologies and different engineers to manage microservices, and a service mesh can bring this all into a single place for uniformity, let's say, in a sort of a polyglot world, and indeed replace the effort of multiple engineers. I think as microservices push software development and execution to become more granular and distributed, new ways of authenticating and controlling are needed, and really service mesh is coming to view as really a first-class citizen in terms of supporting this. So when we've asked of our panel which cloud-native technologies are most important to the DevOps, we can see here that that microservices, I think, really we can think about as the organizing principle or the end goal, because it's pretty clear that enterprises can be faster and more agile using microservices, and then we've got all the things that support that. I think clearly as all of these increase in momentum, that's going to bring service mesh with it, because as deployments scale up and get faster, they're going to need ways to to figure out how to manage all of these things. So when we double click a bit just on where we are with service mesh itself, well, the sort of emergence of containers and almost threatens to, or promises, I should say, to really simplify how apps are developed. But there's such a breadth and depth of things that are available now. I think the key to success is going to be finding the right combinations, operationalizing them, and making sure they are delivered at the right time and the right place to deliver these, the benefits as advertised by their suppliers: speed, agility, scale, and cost. But it's clear, however, that the adoption of the service mesh piece right now is, it's pretty early doors still, and the simplification of that the service mesh brings to large distributed teams is, well, it's foregrounded by companies using service mesh at scale at the moment, and they are, sort of taking advantage of the technology environment simplification, running Kubernetes using containers and so on. And indeed, vendors suggest actually that organizations employing anything more than one team should also be able to gain the benefit from using a service mesh. There are, however, well sort of understood operational and performance overheads, include because of the sort of complexity and scale. And I think that's really the main sort of challenge that the industry has to address here. And with all the moving parts in microservices and the complexity of service meshes, these really need to be wrangled, and especially when we consider Istio. But I think in just looking at where we're going in 2020, I think there's going to be a focus on the people and process and operational aspects of service mesh with new abstractions and packagings and so on. And there are already some managed service mesh offerings in the market, and I think there'll be other and new approaches coming along on stream as well. So cloud adopters are pretty enthusiastic about using service mesh to consistently apply routing and policy and encryption across microservices, but it's been difficult, not least because of fiddly configuration and management and so on. And there's lots of things in the market, but I think that's entirely to be expected at this stage of market development. There's the market's thrashing. There's a lot of complexity. There's lots being literally made up as we go here, and I think clean and simple stories are going to be important. And what we did is to aggregate the benefits which have been supplied in the various use cases and use studies by vendors, and I think there are sort of these four groupings really where service mesh has seen use, and end users have articulated specific benefits. I mean, if we think about overall, a service mesh appears to be a good way to dictate behavior and therefore application outcomes, optimizing cost, decreasing risk, and then ultimately that translates into improved business outcomes and a better customer experience. If we then turn to the who, again the use cases that we have seen and heard both at the vendors, at events, and amongst our network. I mean, they tend to be, companies with scale, complex environments. In particular, retailers with their own shopping carts who've got lots of moving parts. Public sector and SaaS. I mean, just thinking of the companies that shared their experience at the recent Service Mesh Con event at KubeCon. This was companies like Lyft and Uber and Pinterest and so on. So, and what I wanted to do was just finish up with just some lessons learned in terms of what Service Mesh end users have shared with our team here at 451. And again, I kind of collected these up. And I think it's instructive in terms of just taking a review of what organisations' experiences are have implemented at scale. So first of all, the collaboration piece is really I think that gets at the heart of the matter in terms of encouraging service owners to opt in, the ones who have got the most to gain, and to get the implementation off on the right foot, and identify and get buy-in from those who are likely to be most affected. So starting with Ingress, so establishing a consistent way for external apps to call into the mesh. I think vendors can deliver sort of an easy button, if you like, for onboarding and run book for customers to get started is going to be an Ingress here is a useful first step. So prioritizing security, a primary use case is to ensure MTLS encryption of service-to-service traffic, and application and sidecar communications need to be pretty solid. So, with so many layers of software-defined interaction, bugs can, well, they can find their way in from so many places. So having a consistent way to deal with that is important. Service mesh involves a big change in how services communicate, so planning needs to be done around the migration. Features that can cause problems, during implementation, even if they're not active, just use the simplest set of tools that can address what you're trying to solve. Never stop investing in performance improvements. Main downsides of service mesh are latency and resource consumption, and chatty connections and so on. Rolling out slowly, start small, scale up, begin with a use case that's not in the critical path. I think, or one thing I think is that if you do service mesh just for one app and then don't roll it out, it means you might end up with a pet rather than cattle. So roll these updates out sort of slowly and planfully, and be careful of new connections. But most importantly, just keep the faith, because despite the difficulties, I think the adopters we've spoken to say the benefits make the difficulties worthwhile. So I hope that was a useful kind of overview. I'm going to turn the webinar over to the good folks at the Ygrene Energy Fund and Aspen Mesh. And I'm happy to share the research with anyone who wants to be in touch at the end of the webinar as well. Thank you.
Thank you, William. I really appreciate it. Hello, and good morning, or good afternoon, good evening, whenever you're watching this. My name is Zach Arnold. I work as the Vice President of DevOps Engineering, most recently with Ygrene Energy Fund. Briefly, Ygrene Energy Fund is a property assessed clean energy financing company, and we provide financing to residential and commercial properties. We focus specifically on green energy. Because of the special way that we offer our financing, it's really great for investors, property owners, and governments, because people pay it back through property taxes, which means that we have all kinds of concerns, because we have to make sure that we satisfy the security needs of governments, investors, and of course we want to make sure our property owner information is secure. The majority of the software that we develop is loan origination software, so you can imagine the information that we maintain as far as making sure that someone is indeed approved to be able to receive financing. We are 100% in the AWS cloud, 100% in Kubernetes, and as of last year, 100% in Istio. But that was sort of like pulling teeth, and one of the most complicated engineering projects that we had. The reason we went down this path was basically we wanted to be able to give a guarantee to everyone that everywhere you go, anywhere inside of any network that Ygrene is associated with, all traffic is encrypted using MTLS. At the time, we were using implementations of manual certificates, so we had our own certificate authority, and we were distributing certificates manually, and signing and revocation was a pain, and suddenly services would go down in production, and it's like, oh, turns out it was exactly 1 year ago today when we issued that certificate. I bet that's why that happened. So we thought it would be really great, since we already had Kubernetes, if there was an existing solution. And it turns out that at the time, the only solution that existed with a mature MTLS implementation was Istio. That landscape has since changed, but we have not reevaluated our decision because of the sheer amount of effort that went into it. Istio had just gone GA and probably wasn't ready for production. And we compounded the problem by also trying to get it to work on the very first version of Amazon EKS, which had it was missing some fairly fundamental Kubernetes concepts. And of course, that team has since remedied that as well. After getting it into production, we basically had the worst time operating the mesh. There were so many concepts that seemed to do the exact same thing, like virtual services and service entries, and then suddenly policies and destination rules needed to be coupled together. And there's a bunch of proper nouns in Istio, much like Kubernetes, but what was worse is it basically augmented the complexity that already existed in Kubernetes. So it was like Kubernetes squared. Bugs were esoteric, extremely hard to find, and not easily reproducible. So it kind of got to the point where we were like, okay, we really need to engage some experts to help us figure out this mess, which is kind of where the Aspen Mesh team really saved us, because as we sort of said, operating Istio in production is non-trivial, at least still today. I mean, Kubernetes can keep the control plane up and live and make sure that the sidecars are being distributed, but it leverages a lot of fairly advanced concepts that, if not working in perfect concert, there will be extremely interesting ways that network traffic can fail. So I would say in our engagement with Aspen Mesh, one of the things that they started doing is from day one, they figured out the esoteric issues. We had I want to say it was an Istio pilot configuration that was due to the fact that we disabled an admission controller, so nothing was being validated, and it couldn't push that to an Envoy sidecar, so deployments failed. It's like the randomness of that amount of things that had to go wrong in order for us to see the result was surprising, but the team was extremely helpful, extremely quick to debug, and they helped us dramatically simplify our encryption configuration. And to explain how they helped us dramatically simplify our encryption configuration, I'll turn it over to Neeraj, who basically helped save our bacon.
Thanks, Zach. Thanks for giving a great overview on the problems Ygrene was trying to solve with Istio, and then the problems they got into it with Istio, and William for giving us and painting a great picture of the CNCF landscape. Hello, everyone. I'm Neeraj. I'm the co-founder and engineering leader at Aspen Mesh. Let me just start off by giving a brief overview of what Aspen Mesh is, and then move on to the specifics of our engagement with Ygrene. Aspen Mesh is a enterprise-grade supported service mesh built on open source Istio, which enables organizations to achieve, to be successful in their digital transformation journey. We provide an advanced policy framework that allows organizations to achieve business outcomes around security and user experience, at the same time giving visibility into the environments so they can reduce their mean time to detection and remediation for any failures. In our engagement with Ygrene, like Zach was saying, we started off trying to understand the environment, their use case, and the specific problem they were trying to solve. Security was a key concern for Ygrene, and they wanted to make sure traffic within their cluster is secured using mutual TLS. Like William was saying, the key point here is we wanted to make sure their adoption journey is as simple as it can be, and we wanted to abstract away and hide some of the complexities of Istio. And that's what inherently Aspen Mesh does. A second big requirement for Ygrene was that they wanted to make a resilient infrastructure on Istio and wanted to make sure if there are problems with Istio, they can easily debug and understand. Zach and his team are already Kubernetes experts, and they wanted to make sure anything in the infrastructure they have a good understanding of. So a lot of our engagement with Ygrene was making sure we work with them to understand and explain how configuration flows in the system and give them all the tools in the toolkit so that they can operate and debug Istio in production. One of the key things to be successful in Istio is making sure that you are incrementally adopting Istio and using it piece by piece. Like William said, there are various things that are triggering enterprises and companies to use Istio. Some of them can be using Istio for policies and securing the environment, which might be due to compliance or regulatory reasons, or they want to gain visibility into the environments, or they want to just make a resilient system. It's great that Istio provides all these capabilities, but if you turn all of them at the same time, you're going to have a challenging time. So that's what the first thing we worked with Ygrene was to understand what they needed, and what they needed was MTLS and security. With MTLS, even though Istio gives it out of the box, there are quite a few sharp edges that you have to deal with. You can configure mutual TLS at global level, namespace level, at a workload level, at port level, and you have to configure policies for the services or the clients. The tricky thing here is the policies that you're configuring can be conflicting with each other. And once they conflict, you can have traffic failures, or worse, you can actually have security escapes where you're thinking your environment is secure, but actually the traffic is flowing unencrypted. With Aspen Mesh platform, what we do is we make sure we inspect the configuration that is currently existing in your platform, and then we automatically generate all the Istio configuration for you depending on what your end state is. So out of the box, we have MTLS enabled globally, and then you can visually, through our dashboard, go and disable MTLS or enable MTLS piecemeal, and we will generate all the configuration which you can take in and you can apply in your CI/CD pipeline or apply in your clusters. This way, even though MTLS configuration itself might be quite complex, all of that complexity is hidden from you. Another thing that our engagement with Ygrene we found interesting was we wanted to make sure Aspen Mesh worked in their environment seamlessly. What that means is Ygrene came to us where they had a working solution for ingress. They had a solution for telemetry where they were using Datadog. So we customized our distribution to make sure Aspen Mesh can integrate with it without causing them to rip out all the pieces that they have already built. This is another great functionality that you get out of Istio and Aspen Mesh where, where you can choose the pieces you want and make it work with your existing infrastructure. This is another thing that we often get into when we are early on engaging with our customers. We try to figure out the existing environment and make sure we adopt our solution for the needs. For example, some of our current customers are just migrating into a greenfield environment and they want to securely get traffic into the cluster, like William said, is one of the things that you should start with. So in our policy framework, we have a secure ingress policy, which easily allows users of our platform to map the application needs and the platform needs into specific resources, convert it into Istio resources automatically, where now securely you can get traffic into your cluster, get certificates from Let's Encrypt, validate that the end user is presenting a valid chart, and so on and so forth. The next thing that Ygrene really wanted from us was the expertise on making sure they have a resilient environment. For this, we made sure in our distribution, we enable all the tools in the toolkit that can help them fix issues if they find something. These are the lessons that we have learned by using Istio in production since early days in our platform, and also just being Istio experts since we are active contributors to the Istio community. First thing is you have to do incremental adoption. Like I've been saying, some of the other tricks that you should be doing is make sure you have Envoy access logging enabled. This is your first level of defense that makes sure that you are getting visibility into the traffic that's flowing into the mesh. The access logs gives you information about the request, the client, and the destination. And more importantly, if you have failures in your microservices, you can see at which hop the failure happens. The next key thing is configuration validation. We have an open source tool called Istio Vet that looks at configuration that is currently deployed in your cluster, figures out if there are configurations that are interacting in a way that conflicts with each other. So you can have gateways that are pointing to ingress resources that don't exist. You can have virtual services that are in conflict with each other because they have the same host name. So we look at all of those and generate warnings automatically for you. The key here is to get to know these failures early on in your system so you don't even deploy those configurations in your production system. We are excited to say that in Istio release 1.4, we have been working with the community where now this capability is baked into upstream Istio through a tool called Istio Analyze, and we'll be moving more and more of our functionality into upstream Istio. The last thing is you have to make sure you are monitoring the Istio control plane, taking into account all the errors that might be happening in this complicated distributed system, and at the same time monitoring the logs and making sure you have alerts set up. So if there are failures in your control plane, you don't have policy and security violations. In summary, I would like to say that the three key takeaways for anyone who wants to be successful with running Istio in production is make sure you incrementally adopt Istio, identify the pieces and the use cases that you want to deal with, and then enable just those pieces. Understand the Istio's architecture so that you can plug in the right pieces and ensure that your existing systems work with Istio. And third is to have all the tools in your toolkit so you can operate and debug and actually be successful with running Istio in production. To conclude, I will just say if you are currently looking for help with Istio, or if you have actually started working with Istio and you want to scale and operate it in production, please reach out to us and our experts will be more than happy to help you be successful in that journey. With that, I will let Colleen move on to our Q&A section. Thank you.
Thank you so much to all of our speakers. It's now time for our Q&A session. As a reminder, simply type in your question in the box on your screen and we will get to as many as we can. The first question is for Neeraj. When is the right time to use Istio? Do I need Istio if I only have a few services?
That's a great question, Colleen. So it depends on where you think your company is heading more than what your current state is. Ideally, to minimize the cost, you would need some small number of microservices to account for all the overhead that Istio adds. But for me, the main thing is if you're currently even using a small number of microservices, but your projected architecture and use cases is to add more, it's good to add these things early on so that it's baked into your infrastructure. Your developers are not building the things that Service Mesh provides. It will be harder if you add on later. Even though Istio is meant for incremental adoption, I always recommend if you're planning a greenfield environment and a platform, the best thing a platform operator or a platform owner can do is bake Istio early on and then roll it out to your developers. Thank you.
And the next question, how else can I get end-to-end encryption without the Service Mesh?
Zach, maybe you would also want to answer this since you went through this exercise, but in some of the organizations, they do brave through the effort of creating end-to-end encryption in their own applications. This means importing an SSL library, providing certificates, automating and renewing them. And I think Zach can tell his experience on how that went with Ygrene.
Sure. Yeah, and thank you, Neeraj. But to be clear, like the M in MTLS just means both sides verify the sending certificate and make sure that it's valid and signed by a CA that they both trust. So there's nothing mythical going on in terms of how Istio is encrypting traffic. It's standard TLS. But obviously, if you're going to reproduce that, that means that you need to run a CA, you need to sign certificates, you need to distribute them, you need to rotate and revoke them. So, yeah, I mean, I guess if you can, like, you know, if it's a Java app, all of them have cert stores and key stores. And I want to say we just use Kubernetes secrets and then mounted all of the various client certificates and client keys into the various services. It's just a pain to manage. And you know, when you have a DevOps team as small as ours, the more that you can delegate to something that will handle it for you, the better. So yes, it can be done without it. But if your setup necessitates a lot of automatic policy configuration and a lot of automatic revocation and cert distribution, why not just let a tool that already does it and has already passed numerous security audits by public companies to do that?
And our next question, how can I increase the global HTTP timeout in Istio? Few of my services are making requests to external endpoints and getting timeouts because of Istio 15-second global timeouts. Services typically respond back in 20 to 25 seconds. I read about virtual service to fix that, but no luck. Any ideas?
Thanks for asking this question. It's kind of tricky, and that's why I wanted to make sure I give the right information here. Even though they are virtual services defined, those act on a particular host. To configure the timeout setting globally, I think currently you are stuck with using an Envoy sidecar API or the Envoy filter API. I'm sorry, that lets you configure and change the timeout settings on a global level. The filter API is kind of a break glass API, so I would advise some caution when using it. Please reach out to us. I'm on Istio Slack, and I think our company email was present on the slides. I would be more than happy to make sure that you are successful with that. I think there are quite a few options. We just want to make sure that we give you the safest one.
Zach, next question is for you. What advice would Ygrene offer to organizations just starting out, such as are DIY approaches too complex? Does a managed service always make sense? And any gotchas to look out for?
Sure. That's highly context dependent. So I can't give a definitive, this will work and this is too complicated. I would say when we adopted Istio, it kind of felt like we were in a covered wagon headed west for Oregon, because like there were no even questions on Stack Overflow, much less answers. So in the tool that we adopted, it was very much so early days, but that doesn't necessarily mean it was the wrong tool or the wrong choice for us at the time. So for people just getting started, I mean, obviously we have a vendor on the phone call, and they certainly helped us a ton, so engage them. They're extremely knowledgeable, and if during the course of the POC or some engagement they decide, hey, maybe service meshes aren't for you, then they would totally say that. So it's always worth having the conversation. But DIY approaches make sense when either the policy rules that you're trying to control traffic with are more granular or more complicated than can be expressed with the grammar that Istio provides, or that the subset of features that you need from Istio are so small and well-defined that it obviates the need to even have all of the complexity that it involves in running a control plane and a data plane for a service mesh. So I would say those are the two kind of deciding factors.
And Neeraj, in Aspen's experience, is service mesh suitable only for scale microservice deployments? When else would it be useful?
So I think if you're asking about if service mesh is useful for scaled microservices deployment, yes, it's definitely useful in that scenario. Even if you have a smaller scale deployment, I would say sometimes due to compliance or regulatory reasons, you might need more security, in which case it makes more sense to have those tools in your toolkit where the operations team are responsible for doing it rather than your developers. Similarly, irrespective of the scale, you always want to know what's happening in your cluster, and service mesh gives you a lot of visibility through tracing and metrics out of the box, which otherwise, again, you have to bake into your application. So I think a question of scale does arrive here, but I think it's more about what business outcome you want to get, and then evaluating if service mesh is the right tool for you.
And we have time for one final question today. What are some of the operational challenges around scaling Istio?
I can take a stab at it, and then maybe Zach can answer this too, since he has actual production experience. So some of the challenges I think that companies have seen with using Istio, especially in the early days, has been around scaling the control plane, which can consume a lot of resources, or scaling the sidecar, as if you have a large number of pods in your system, the sidecar can consume a lot of memory. So we have been working with the Istio community for the past year and a half and making a lot of advancements. I can say I've seen customers use Istio for more than 300, 400 pods now successfully. Some of the new APIs that we have added, for example, the sidecar API, makes you prune the configuration that is sent to the sidecar, so you only need information about the things that you're talking to. So things like that. Another thing being removing mixer from the system. So now the telemetry is reported automatically by the sidecar, so you have less and less things that you have to worry about. going forward, I would say in Istio 1.5 and 1.6, we would even see further enhancements around how the Istio control plane is deployed, which will make it easier for Istio to scale. Zach, anything else you might want to add?
Yeah, I mean, most of my experience is basically previous versions of Istio, which is a whole lot of guess and check, which was probably not the answer that anyone wanted to hear. Scaling Istio was more a concern on, as Neeraj said, resources than it was a concern on whether or not the policy definitions worked or whether or not the throughput was manageable. Again, we actually noticed a performance improvement when we introduced Istio because it was holding open TCP socket connections for us. And I think I said this at a talk one time at KubeCon in Seattle. Basically, like our request time is measured in minutes and days because we're running a financing application and we integrate with a lot of legacy vendors. So sub-millisecond latencies are not even on our roadmap, but obviously Istio had a non-trivial impact to the amount of pods that we were going to have deployed in our cluster and the amount of nodes we would need to have in order to keep that resilient. At the time, we were running a lot of our infrastructure on EC2 Spot, which felt like a very cavalier idea at the time and ended up being not as cavalier as we wanted because of stability issues. So I would say if you do plan to do that, ensure that the Istio control plane remains on instances that are dedicated. And I think that's really the two major concerns, nodes and availability.
Thank you so much to all three of our speakers today. That concludes today's webcast. As a reminder, the on-demand replay will be available on On24 soon. On behalf of Aspen Mesh and 451 Research, thank you so much for attending and have a great day.